Hello everyone, I'm sure you are doing perfectly well. This is mathematics, and in this video we are going to look at 2019 GCE paper 1. So this is the first video, then we'll also look at the second. Okay, it's the first part, then we'll also look at the second part, depending on where we are going to end. Alright, so I'm not only going to answer the individual questions set in this paper, but I'm also going to give you some of the concepts that you are supposed to know. In case the question is arranged in another way, you will have no problem with that. Okay, this year personally I want you to make it. I want you to pass without any doubt. Okay, so please, you have to be following whatever I'll be doing here. Okay, let's get started with the first one. Simplify the first question here. Simplify 4 minus 2 in brackets. We have b minus a outside -1. This question is from algebra. Okay, they are asking you to simplify, meaning make it easy. Okay, that's to simplify. So there are brackets here. With brackets, that's the first thing you target there, to remove the brackets. Brackets, remember, it's about multiplication. So the way it is here, I'll say 4, I'll start now multiplying so that I get rid of the brackets. This is paper 1. I repeat myself. Calculators are not allowed, and omission of essential working will result in loss of marks. So meaning you have to be showing stages. That's when you earn a lot of marks. Okay, so we have 4 here, then we start multiplying. Bracket here means multiplication. So we have -2 multiplied by b here, and that will be -2b. Then the negative times negative, negative times negative here will give us a positive. I see that. Then 2 times a, that will be 2a. Then outside we have -1. Okay? From there, next concept that should be here is about collection of like terms. Do we have like terms here? We have 4 and the 1. They are like terms these. So we have 4. I can group now the -1 there, bring it here. Then this, which is -2b plus 2a. No change of signs with this simplification here. Okay, no change of sign that when it crosses the equal sign it becomes negative. Nothing like that in here. Like you are able to see. The -1 now. Quoted this -1, put it there. The sign remains negative the way it is. Okay. And then from here, these two can be subtracted. 4 take out that gives us 3. Then -2b plus 2a. You cannot add or subtract. They are not like terms. So write the way you are able to see them. -2b plus 2a. This expression can not be simplified any further. It will be just like that. So you leave it there. Okay, you leave it there. The other thing that maybe you can do is to rearrange so that they are in correct order. And if otherwise, this is 100% correct. It ends there. If you want now, that's when you can now start maybe with a, 2a, then b, -2b, then the last one, this. It's the same and one and the same thing. Okay, so this is how to go about it. By showing this, you will be able to see that if this, for instance, this it was 2 marks. Okay, so the 2 marks, the way they will calculate these 2 marks here will be the method here. This is the method. So they will write method mark MM1. Okay, then the answer also AM, answer mark 1. You get your 2 marks. So that's the way the breakdown is done. Okay, let's move on to the next question 2. Question 2 is to evaluate 4 roots of 81 in brackets to the power 3. This is under indices. Okay, this is indices there. So they're asking you to find the value without the calculator. Okay, and method must be shown as well. The calculator, if you use the scientific calculator here, it will just give you the answer, boom. But we are talking about the method. How are you going to get that same answer? So you have to get the meaning of this. 4th root of 81. What do they mean by that? Okay, fourth root of 81. They are saying you have to look for the number that you can multiply itself how many times? 4 times. You multiply that number 4 times and it should give you what? 81. What number will be that? Okay, so remember again that this, the entire thing here, I can also write it in another way. That is change of indices there. The way it is here, this is power, this is root, isn't it? And the 81 here. So this, the entire thing here, the same as writing like this. 81, what's the power? 3 over 4. So this is the same as this, okay? Because this one we say this is power on top, the numerator is power, the denominator is the root. So this can be expressed in that way. It's the same thing, okay? So now what are they asking us to do? Fourth root, meaning 4 times. The number that we can multiply itself 4 times, it should give us 81. So that number will be 3. Okay? So you can now try to say 3 times 3 times 3 times 3. 4 times. This is the meaning here, okay? So that gives us 9 here, multiplied by 9, and that is 81. So the fourth root of 81 is 3. Then this 3 is just for what you have calculated inside. But it is e to the power 3. So 3 to the power 3, we are saying 3 times 3 times 3. And this will give us 27. You are done with that. Okay? That is how to answer that one. Next question, 3. Factorize completely is the next question here. Factorize completely. 32 x squared minus 50. Okay? Remember factorization can be in grouped form. Okay? Factorization by grouping. We also have difference of two squares. We also have quadratic expressions. Okay? So you have to identify the type. Okay? If it has got 2 terms, like the way it is 1, 2. If it has got 2 terms, then that is the difference of 2 squares. 3 terms, if it has got 3 terms, it can be x squared plus 2x plus 3. This is 3 terms. If it is like this, then it is quadratic factorization. If it has got 4 terms, then that is grouping. We can have a factorize ab squared t plus bc plus dc plus 4ac. Are you seeing that? 1, 2, 3, 4. So here it's about grouping. So look at that question. So this question is the difference of 2 squares. Difference of 2 squares. But how do we go about that? You get the question the way it is. 32x squared minus 50. Difference of 2 squares is about expressing the given terms in square form. That's the bottom line. Expressing the given terms in square form. Now, if you look at this, the only thing that has been squared is x. Is there the number that I can use to square 32? Or does it have the square, can it be expressed in square form? What of 50? You find that these 2 numbers cannot be expressed in square form. Then what is it telling you? We are going to do what we call common factorization first, before the real difference of 2 squares. Common factorization, we are going to look at a number that can go into 32 and 50. 32 and 50. What number will be that? You agree with me that that will be a 2, huh? So we can use a 2 here. Then how many 2's are in 32 here? So you find that there are 16, okay? Then we have x squared here minus how many 2's are in 50? That gives us 25. Okay? At that point now, the 2, you just be coming with this 2 until the final answer. Your job is now to concentrate on what is here, the brackets. Okay? So now you can see that 16 can be expressed in square form. 25 can also be expressed in square form. If you leave it here and you think maybe you are done, you have not done anything there. Okay, so now we express everything here in square form. So I'll write the 2 here, the way it is, and then I'll have 16 in square form. That will be 4 squared. You see? Then x is already squared, minus 25 will be 5 squared. Everything now in brackets here. in square form. What next? If you express everything in square form, ignore the squares now. Okay, ignore the squares. So we have the squares here. You ignore them. Then, once you ignore them, then we have 2 here. What has remained here, the base, it is a 4. And then x here minus, the other one will be 5. Then the other bracket now will be, you just change the sign to have a plus, which is 4x plus 5. You are done. If you want now, you can even introduce square brackets like that to show that the 2 is for everything there. You are done. Just like that. Let's go to question number 4. Question number 4. Find the gradient of a line which passes through -5, 3 and -4, 1. This is coordinate geometry, okay? Coordinate geometry. So what we are asked for is the gradient given 2 points. What is just needed there is a formula. Then you are done. So for gradient, first of all, before the formula, you can now label this x1, y1, and yeah. So we have x1 here, y1, then this one will be x2, y2. Here, I've seen mistakes whereby you say x1, y2. It doesn't work like that. If you begin with this to be your ones, then 1, 1, this side 2, 2. There's no problem again if you say 2, 2, 1, 1, but not 1, 2. And also, the first number is always x. Even here, this is x. Second, y, just like that, okay? So please, you need to take note of this. So after you do that, now write the formula. Gradient is m. Okay, we use the letter m for gradient. What's the formula? y2 minus y1 over x2 minus x1. That is for gradient. Put those numbers in there, or replace, which will give us y2 is 1, so I have 1 there, minus y1, here 3, over x2, here -4, minus x1, which is -5. So we have -5 there. Then we simplify this to have our gradient, which will say 1, -3, that will give us -2, over -4, so we have -4 here, negative here is +5, okay, which will give us -2 over -4 plus 5, that will be a 1, okay. Now, you cannot leave the answer in this form here, -2 over 1. No, over 1, that is the same as now -2. You just get the -2. So this is your gradient, okay? That is your gradient. In exam, I'm writing it in this way because I'm looking at the space left. In the exam, don't go in this way, okay? Make sure it is tabulated in that way. Well, that is about this. Coordinate geometry has got formulas. Okay, it has got formulas. Apart from this, for the gradient, they can also ask you to find the midpoint. The midpoint, we say x1 plus x2 over 2, comma, y1 plus y2 over 2. That is for the midpoint, okay? We also have other formulas. This one for the midpoint is when maybe you've got this point and this point, then they want the number which will be in between, okay? Or I mean the coordinate that, or the point that will be in between, that is what we call midpoint. So this is the formula to use. You do the same in terms of putting the numbers there, okay? We also have distance, okay? For distance, we say they must be square root here, x2 minus x1 squared here plus cy2 minus y1 squared here, okay? So this one is when you are looking for the distance between the 2 points. This point here and this point, what will be the distance? You use that formula, okay? If you're asked to find maybe you're asked to find the equation, okay? The equation of the line, which we can say, you are asked to find the equation of the line given 1 point and the gradient. Maybe they say gradient is 2, and then we have got 1 point, which is 2, -1. Find the equation of that. You use the formula y minus y1 is equal to mx minus x1. You are done. Start putting, meaning here there is only one coordinate. This will be your x1, y1. You are done with the formula there, okay? And then given 2 points, okay? You've got the way the points were this point and this point. They ask you to find the equation. What formula do you use? So you say y2 minus y1 over, sorry, not that one. You say y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. That is the formula to use, okay? But then we also have what we call the gradient intercept form. The gradient intercept form is written in this way: y is equal to mx plus c. This one is you are given an equation. Okay, we can say 2x plus y is equal to 7 here. Then they ask you to find the gradient of this. Okay, so to find the gradient of this, meaning you have to express this equation or making y subject to formula in this way, okay? Making y subject to formula. After making y subject to formula, the number or the coefficient of x gives you the gradient you are asked to, okay? And then we have perpendicular lines, perpendicular as well as parallel lines, okay? For perpendicular lines, for parallel lines rather, it's just straightforward. It's the first gradient. So we have m1, m2 is equal to -1. So first gradient, that is for parallel. Second gradient is for perpendicular, okay? The application is well known there. Okay, the other thing that you need to know is about collinear points. Okay, collinear points have got same gradient, and they lie in the same line. So basically that is about that. Let's move on to the next question. Question number 5. This one is about sets, okay? It's sets. The Venn diagram below shows 3 sets, A, B, and C. So there was this, okay? Then the question is, use set notation to describe the shaded region. So this is the shaded region. So now the way, usually these questions, the way they come, one way is in this way whereby they've already shaded this, and then they will ask you to look for the set notation representing this shading, or they will give you the set notation, then they'll ask you to shade. Okay, so now if you look at this, we want the set notation that will represent this. We've got A, B, and C. Okay, we've got A, B, and C here. And then the part which is being shaded is C, part of C, not the entire. They've excluded what? A and B. So excluding A and B, what should be here has to do with the complement, isn't it? Complement means outside. So if you look at A and B, it's a combination of A and B. So that combination of A and B in set language, that is A union what? B. You put them in brackets. So A union B, it will be this region, isn't it? It will be this region. But this is not the region which is being shaded, meaning complement here. You see that? So A union B complement, okay? Then we have intersection. Intersection, don't use the union here, because if you are saying union, then the other parts will be also affected. But intersection C, you are done. You get the entire 2 marks just there. Okay? So now you can now even try to test if this is true. You can test and imagine now that maybe I've been given this. How would I take it back to this so that this shading becomes true? What you do there is you come up with a diagram, the Venn diagram of the same kind, where I'll say, got these 3 here, okay, for testing. I want to see if at all this is correct. Okay, so there you say A, B, C, then I've got my E there. Put any numbers of your choice there, okay? So we can say 1 here, 2, 3, 4, 5, 6, 7 there, okay? And then what I want to test is this, if this will match this position here. Okay, so here I'm saying A union B. Seeing that? A union B, meaning I should combine. A union B. So my A union B, it will be, this is A and this is B. Now they are saying what? Complement. Meaning A union B funyako fiancefi. That is the meaning of that complement. So the set that will remain for this entire thing here, the number or the set that will remain will just be what? A 7 there. 7, I can write the 7 there, okay? And then it's like now I'm solving the set. And then I've got intersection here. Intersection, you write the intersection C, okay? Set C. So set C is this one here, this entire set, that is set C. Then write all the elements that are in set C. So I've got 3, I've got 4, I also have 3, 4, I've got 6 as well as 7. Then look at the two given sets here. You see? And the symbol in between is intersection here. What is intersecting this and this set? You find that it is a 7. So my final answer there is what? 7. Then I'll be able to shade where this will be. Where is it? It is here. So you can see that this is matching that. So that is how to answer these kind of questions, okay? Question number 6. Question number 6 says the vector PQ is equal to negative 3, 2, given that the point P is 1, 4. Find the coordinates of the point Q. So this is a combination of vectors together with some concepts or ideas under coordinate geometry, okay? So now we are saying the vector PQ. So we are talking about what we call position vectors, vectors from the origin. So the best thing to that you can do here is come up with a diagram of this nature. Okay, where I'll say P, point P here, and also have point Q there. Then I'll join, and then they are coming from the origin there, O. Okay? So now from the data given here, I'm being told that the vector PQ, meaning from P to Q, in that direction, I've got that in component form. I've got this is the vector. Okay, so now this is in vector form or in component form, of which now I can write it's just the same when I write it in coordinate form. PQ. I can say PQ, this is the same as negative 3, 2. Okay, so this is the same as this. This point you are seeing here, 1, 4. 1, 4, that's the same as writing like this. 1, 4. Okay. So if it is in this way, then we are talking about component form, or in this way, this is component form or vector form, then this is in coordinate form. Okay. So now the whole idea here is you need to know how we move in terms of vectors. Remember, it's a quantity that has got both magnitudes as well as direction, isn't it? So looking at this, I've been told that PQ is this. So I'll say PQ, vector PQ is equal to, you are here, okay? This person is here, you want to be there, you're going to move. You always start from where you are, meaning P to O, so I'll write PO here, okay? Plus C O Q, then I'll be O Q there, okay? So in that case, in this, then I have to use the data given here. I'm looking for the coordinates of the point Q, meaning here, this is where to, that's a question, okay? So position vector of, for instance, if I say what's the position vector of A, that is OA, okay? Position vector of B, that is OB, okay? So that's the idea. So when you say OQ, that is the same as point what? Q, that we are looking for there. So what we are going to do there is now to make some substitutions here so that we have, we can find what we are asked to. What is PQ? Being told that PQ is this, so substitute negative 2, 3, and the 2 there is equal to, what is PO? They are saying, given that the point P is this. So from what I was from explaining here, the position vector of P, I said OP. Okay? position vector of the point P, that's the same as OP. So in short, what I've been given here is OP, and OP is here, I'll write it in this form, 1 and 4. That is my OP. Okay. Now, what is here is PO, opposite. So this does not mean you get the 4 here. It's just a matter of changing signs. Okay, that is opposite. Negative becomes a positive. Positive, negative. So the way it is here, the changing OP to PO here will be, since this is positive, it will be negative. So I have negative 1 here. This is positive also, it will be negative 4 here. You see that? And then plus the one that I want here, which is OQ. You see that? Which is OQ. Then to get my OQ, now it's just a matter of rearranging so that I just remain with OQ this side. Meaning this will go on the other side. And this side here is positive. So when it crosses the equal sign, that becomes minus. It's more like now it's an equation here. So we have negative 3 over 2 here. Then this crossing the equal sign, we have minus here. Then the way it is negative 1, negative 4, because this side I'll remain with OQ. Okay, I'll remain with OQ there. And then doing some calculations there. Sorry, I had to put this. Never should do that. Okay, so these calculations here, so we are going to have negative 3 minus 1. So we have negative 3 minus negative 1 there. And then down we have 2. Okay, we have 2 there. Minus negative 4. Like that. Is equal to OQ, the one we want. What next? We find the answer now. So looking at this now, to be negative 3, so I'll say my OQ will be equal to, let me use this part here. So my OQ here will be equal to negative 3, negative here is positive. Huh? So we'll have negative 3 here, negative, that is positive 1. Then bottom here we have got 2, and then negative, that is plus 4. And then my final answer now, OQ here, will now be equal to negative 3 plus 1, that is negative 2. And then 2 plus 4, that gives me 6. See that? Then I'll say therefore Q is equal to, this one now in coordinate form, I'll say negative 2, 6. Yes, done. That is how to go about this. Okay? Next question. Question number 7. Question number 7 says, given that R is equal to 2, negative 1, 1, 3, and S is equal to 1, 0, negative 4, negative 2, 1, 1. Find ST, meaning you find this matrix transpose, and then the other one is RS, you multiply. Okay, so this is from matrices, that's the topic there, matrices. So the first part is to find our solution here, which is our A, is to find ST, okay? S raised to the power T. The T is for transpose, okay, the transpose of the matrix. So which matrix are we transposing? Matrix S. To transpose means you have to interchange, the row becomes the column becomes the rows. Okay, so this is our S. Okay, this is the matrix we have. So we'll say now S transpose will be equal to, so I'll transpose. The first row will become the first column. So the way they are, this first, you transpose it, it will be 1, 0, negative 4. Okay? Second row will be the second column. So this now will be negative 2, 1, 1. You are done. Okay? That is the way to go. B, RS. Here it's multiplication. You are multiplying matrix R and matrix S. R is this, you substitute there. So we have 2, negative 1, 1, 3, And then our S is 1, 0, negative 4, negative 2, 1, 1. Okay? So these are the two matrices that we are going to multiply. Now, it's not all matrices that can be multiplied. Some matrices cannot be multiplied, but you can test to say, oh, this matrix here can be multiplied, or why should I waste time here? Okay, how do we test? Get the order of the given matrices, okay? So looking at this, the order of this is 1, 2, which is 2 by 1, 2. This is a 2 by 2. The order of this matrix here is 1, 2. Remember, when giving order, it's always row times the column. So 1, 2, this is 2 by 1, 2, 3. Okay, so the order of this is here, the order of this is here. Okay, so now how do we tell that the two matrices can be multiplied? So you look at this number here, the second, okay, from the first matrix, as well as the first one from the second matrix. These two numbers should always be the same. If they are different, then don't even waste time. The two matrices cannot be multiplied. Okay, so these must always be the same. So if there's 1 here, there must be 1, 2, 2, 3, 3, just like that. Okay, now what about the remaining numbers? The 2, the first and the last. This 2 by 3. This is now telling us the order of this will now be the order of the matrix that we are going to find. In short, that will be the order for the answer. Okay, if it will not be 2 by 3, then we are wrong. Okay, so that's the principle behind this. You can now start multiplying. Your answer should be a 2 by 3. It ends there. So now we can multiply. Multiplication is always row, column, isn't it? Row multiplied by column. So I've got 2 times 1. I'll have to finish this with the entire components in here, or elements, before I move on to this. So it will be 2 times 1, and that will give me 2. Okay, 2 times 1, 2, plus negative 2, 1 here, times negative 2. So negative gives me positive. Right? So that will be 1 times 2, and that will be 2. Okay, there's no problem. I'm skipping some stages there. Okay, but there's no problem. You can be writing those. Okay, for the sake of accuracy there. So this times this gives you that, plus this times this gives us that. Okay, then we can move on the next part. 2 times 0 gives us 0, plus negative 1 times 1. That gives us negative 1. Okay, like that. Then we move on to this and the last part. 2 times negative 8. Negative 4, that gives us negative 8. Okay, then negative 1 times 1, that will give us, so I'll say plus here, this times this gives me negative 8. Okay, then plus negative 1 times 1 will give me negative 1. I'm done with this, with everything here. Now, I'll move on with that. 1 times 1 will give me 1, plus 3 times negative 2, and that will give me negative 6 here. Okay, then I have done with this and this, and this and this one here. 1 times 0 will give me 0, plus 3 times 1 will give me 3, and this and this, and the last part, 1 times negative 4, that will give me negative 4. Okay, then the plus 3 times 1, and that will give me 3. Then my final step now there will just be the simplification of this. 2 plus 2 gives me 4. Okay, then 0 plus negative 1, this one will give me negative 1. Okay, then negative 8 plus negative 1, that will give me negative 9. Okay, because this will be negative 8, positive, negative, that's negative 1. Same signs as sign from the beginning. Remember there? So we have negative 9 there. Then here, this will give us negative 5. Okay, because this will give us a negative here. So that's 1 minus 6, negative 5. then here this will give us a 3, then here this will give us negative 1. Okay, this is our final answer there, negative 1. So now you can even now test to see if this is the correct order. What's the order? 1, 2, so it's a 2 by 1, 2, 3, 2 by 3. This is what I was talking about. Okay, so you have to be very, very careful in terms of the idea here. Remember, time is also part of the exam. Okay, there will be 23 questions in paper 1. You have to be working with that. Be fast, but accurate. Okay, so let's move on to the next question. Question number 8. So question number 8 says, for the sequence negative 10, negative 7, negative 4, negative 1, find the first part 17 10. Then the second part, sum of the first 20 terms. This topic is sequences and series. Okay, sequences and series. And the two types of sequences that we discuss here are the APs and the GP. Okay, so meaning arithmetic progression and geometric progression. In most cases, mostly paper 1 is AP. Okay, then paper 2, that's why you find GP there. Okay, so now looking at this question here, we are told to find the 17th term. In paper 1, you will not be given formulas for AP. Okay, but in paper 2, you'll be given formulas for GP. So now what you do here is, this is the sequence, which will be negative 10 here. We have negative 7, we have negative 4, we have negative 1. This is the sequence. Okay, now we want to find the term that will be on 17. If, for instance, you've forgotten the formula, there is no problem, you can go on, provided you are fast. You can go on and on and on so that you find this position. How many have you been given here? 1, 2, 3, 4. 4 terms, huh? So you have to go up to 17, you will find the answer there. So you can do it in that way. Okay? But if you want to shorten the process there in terms of time, use the formula. First of all, the data that we need to know here is our A, meaning the first term. So the first term is negative what? 10. Then we also need to have our D, meaning for common difference. If at all this is an AP. So for an AP, to find common difference is always the second, take out first. Or this, it should be common, not here different number or other, then it is not AP. So we can say now negative 7 take away negative 10. You write it somewhere. Negative 7 take away negative 10. Like that. This should be the same answer when I say negative 4. When I say negative 4 here, take away, always take away this side. Eh? So negative 4 take away negative 7. Take away negative 7. The answers here must be the same. Then I'll be able to conclude that, oh, this is AP. So now, let's look at this. Negative 7, positive, negative there is positive. That here, and then here, and this will give us a 3. This will also give us a 3. Are you seeing that? Therefore, this is AP. So, since now our common difference now there is what? Is 3. We've tested, we've proved that it is 3. To answer this question now, the 17th term, we'll use the formula now. For the nth term, we say nth term is equal to A plus n minus 1 D. Okay, that's the formula for the nth term of AP. Where n now will be 17. We want the position there, which is 17. So now we'll say term number 17 is equal to, what is our A? Negative 10. So put negative 10 there, plus C, open bracket, n, which is 17 here, minus 1, and then common difference, which is 3. 3 there. I see that. And then we have term number 17 will be equal to negative 10 here, and then plus, this will give us 17, take away 1, that will be 16, multiplied by 3. See that? Then we have term number 17 here will be equal to negative 10 plus 16 by 3. Be accurate there. You just do this 16 times 3. Somewhere this will give us 18. 1. This will give us 3 plus that 4, right? So we have 48 there. And then the last part now will just be term number 17 will be equal to negative 10 plus 48. That will give us 38. So the term that will be on position 17 will be 38 there. It ends there, okay? Then the other part now, finding the sum of the first 20. Finding the sum of the first 20. Again, if you have forgotten the formula there, it's about adding 20 of them. You list them 20. Start adding. Ends there, okay? To follow the formula, we will say the sequence is negative 10. Negative 7 here, then we have negative 4, negative 1. Okay, so we are finding the sum. So you say sum, the formula there is this sum is equal to n over 2 square bracket 2a plus n minus 1 d. That is the formula. So it must be here. Okay, then from that you make some substitutions here, where I will say sum of how many times? 20. So we say sum 20 here is equal to n is 20 over 2, that way, and then we have 2 multiplied by what is our a? First term, negative 10, okay, then plus n, which is 20, so we say 20 minus 1, put them in bracket, common difference, what did we get? 3. Okay, then we carry on with our calculations here. So say this now will give us 20 divided by 2, that is a 10. Okay, and then 2 times negative 10, that will give us negative 20 here, plus this will give us what? That will give us 19. So say 19 there, multiplied by what? 3. 19 multiplied by 3. You can put that in brackets, and then you say, I think I'll be able to write that side. So sum of 20 will be equal to 10 here, and then I'll have negative 20 here, and negative 20 there. Be careful with the board mass here, plus, and then I have to multiply 19 multiplied by 3. Okay, so I have to multiply 19 and the 3 there. And that will give me this, and this will give me 27, right? Okay, that will be 27. So write 7 there, and then the 1 and the 3, that is 3, plus the 2, that is 5. So I have 57 here. Okay, so I've got 57 there. Then I will move on to say sum of 20 will be equal to 10 multiplied by, I have to find the answer to that. Okay, I have to find the answer to that. 57 take out 20. So I have 57 take out 20 there. Okay, where I will say this will be 7 here, and then this will be 2. So I have 27 there. So I've got 27 there. So my final answer now will be sum of 20 will be equal to, I'll multiply there, which will be 270. And that, so that will be the sum of the first 20 terms of this. It will be this number. Okay? Next question. Well, so by the way, this here, the 27 will be 37 here, right? 57 take away 20. 57 take out 20 will be 37. So here we are expecting 370 there. Next question. Question number 9. The first part. There are 4 blue and 5 white marbles in a bag. What is the probability of randomly picking a white marble? Okay, so this is a bag. So in this bag, we've got how many blues? 4 of them. We also have 5 white. So this is blue, and then we have 5 white. So in short, in total, rather we are talking about 5 plus 4. It's 9. Okay. So 5 plus 4 gives us 9. That is the total number of marbles in here. Now they are saying, what is the probability, the chance of randomly picking a white marble? You just pick at random. So what's that chance? That's the probability we are talking about. So you just say probability white marble. Then you say white marble here. So the chance of picking a white marble will be what? Will be equal to the white marbles. You can only have that chance for the white marble. There are how many in total in this bag? There are 5, isn't it? So the chance is 5 out of the total, which is 9. So 5 over 9. Ends there. Okay? So that is how to answer that one. So it's C, 5 over 9. The chance of picking a white marble is 5 over 9. Leave it there in fraction. Thank you. The second part of the question, number 9, was to solve the equation 2x squared plus 5x minus 3 is equal to 0. You are asked to solve. What type of equation is this? This is a quadratic equation because of that. Okay? So solving quadratic equation is in a 3 form or 3 ways. You can either factorize, you can also complete the square, and you can also use the quadratic formula. Okay? So now looking at the paper 1 type of quadratic, that one, or those in paper 1, mostly you can use factorization or completing the square method. Okay? For quadratic is the one that comes in paper 2. Okay, whereby you cannot factorize that equation, you only need to use the quadratic formula. That's why they give that formula. Okay, if you are not conversant with the factorization or completing the square, there is no problem. You can still use the quadratic equation here. That is if, the quadratic formula. That is if you know the quadratic formula here. You can use it. There's no problem. Okay, you can use it because but the thing is, in paper 1 that formula is not given. So but if you know it and it's the one that you want to use it. So now looking at this equation, how you can factorize, for instance, we'll look for the sum as well as for the product. Okay, the sum and the product. The sum must be the coefficient of the variable given. So in this case here, the variable is x. Right? So the coefficient of x here, or the number next to x here, that is your sum. So here you put the 5 there. And make sure that the equation is arranged in this form, equal to 0. Always equal to 0. Okay? And then the product is the multiplication. Product is the multiplication of the coefficient of x squared and the constant. So you multiply the 2 and the negative 3. Here it's a negative. So 2 and negative 3 here. That will give us negative 6 here. Okay? If there's no number here, then that means there's a 1. Isn't it? So there's a 1 here. If there's 1, you multiply the same thing. Okay? Now, at this stage, you are going to look for two numbers. Two numbers. When I add those numbers, that is sum. When I add, they should give me 5. When I multiply the same two numbers, multiply here, I should get negative 6. What are the two numbers? They can be the same, they can be different. Provided they are the one that qualifies. There will only be two numbers. So to get those two numbers, in most cases, we just get them from the product, the factors of the given product. So if you look at the product here, 6, right? So factors of 6, numbers that can go into 6, right? We have 1, 2, 3, and 6, right? These are the factors of 6. Meaning the two numbers that I'm looking for must be within these. Okay? So what are the two numbers that I can multiply and add? You agree with me that there will be 1 and what? 6. Okay, 1 and 6. Even these two here can give me what I want, but they will not qualify. Reason? There is a negative somewhere. You see that? There's a negative somewhere here. So these will not qualify, even if you test, you get that. So with this in this form here, 1 must be negative in order for me to get a negative here. So I'll look at it the way it is, that this is positive, meaning this bigger number here must be positive. So that is negative 1. So these are the two numbers. Now you can test. Negative 1 plus 6 here, you get this. Negative 1 times 6 here, you get that. Okay, so those are the two numbers. Once you identify the two numbers, now you just write it in this form. You replace this here, okay, or should I say here? You replace them, right? This remains the same, so we have 2x squared here, 2x squared, and then we also have. So I've got 2x squared, then I'm going to replace these two here. So I have negative 1 here. So negative 1, that's the same as negative x. Okay, so I have minus x here. I'm now replacing here. Then plus c. This is positive here. So this will be plus 6x. And then I've got the last term, negative 3 equals 0. Okay, so now you can see now that there are 4 terms there. It's about factorization. And what did I say? If there are 4 terms, then the kind of factorization that will be there is grouping. So you do it this way. Okay? After doing that, we can now factorize here. What is common? We'll find that it is x here. Okay? And then here what will remain will be 2, and the x minus x there is 1. Then on the other side, what is common? We have plus 3, okay, and then 3 in that, we have 2x, so I have 2x here, then I've got minus there. This must be the same as the one that I'm writing in brackets here. 3 into 3, that is 1 there, equals what? 0. So you can see now that what is in brackets here are the same. I'll group that as 1, so I have 2x minus 1, 2x minus 1, I'll just get 1. Equates to 0. Then the other one, the components or the expression outside, which is x plus 3. Also, x plus 3 is equal to 0. So you equate. Remember, it's a quadratic. It should have 2 values. So I can now solve this one and also solve this one independently there. So I have the first one here, which is 2x minus 1 is equal to 0. So this now will give me 2x is equal to negative 1 will cross the equal sign, that will be 1 divided by 2 divided by 2. That then x will be equal to half. That will be the first value, or the other one is here, okay, which is x plus 3 is equal to 0. So the x plus 3 is equal to 0 is just a matter of shifting the positive 3 on the other side, and my x will be equal to negative 3. Okay, so that is about that. Well, ladies and gentlemen, I must say we can end here. The next time we'll begin from, or start from question number 10, going up. Okay, please watch the video and understand the concepts that I've put in these calculations. Okay, so please do that. Thank you very much for watching.